Alright, this video walks you through a few examples of how to convert your parametric equation that has trigonometric functions into your rectangular or Cartesian type equation. And you can see my first example and my caution. You do not want to use the inverse function to then solve for t. When we did this algebraically, that was part of the technique that I suggested, was to solve for t and then substitute into the other equation. When the trigonometric functions are involved, you do not do that. You're going to use combinations of identities, Pythagorean theorem, SOHCAHTOA, just like you've done with other things by the time you get here, the polar equations, the complex numbers, the vectors in different places like that. So the three Pythagorean identities are good because they all have a 1. And as soon as you substitute this equals 1, then the trig and the t parameter both are taken care of at the same time. So as you can see from this first example, I squared both of the equations. I then I added them together, factored out that coefficient 16, cosine squared plus sine squared is equal to 1, and we're left with the answer that is circled right there. The next equation is a little bit more complicated. We have different coefficients in front of the trig, and we have a number that's been subtracted and or added outside the trig there. So we're going to do the same thing, but we need to isolate the trig functions before squaring it. If you just go x squared plus y squared at the beginning, then you have a whole mess, and you don't want to do that. So what we're really doing is setting these up so that when we square, we have that Pythagorean identity on one side that then can be replaced with the number 1, and everything gets going like that. Alrighty. So a little bit of algebra up front. I added the 2 for the cosine, divided by the 4. For the sine, subtract the 3, divide by the 5. Once you've isolated the trig function, then you square it. Now, if you had tangent and secant, you're going to want to subtract in some way. So be careful about, you don't just always add the 2 together. Look at the variation on that Pythagorean identity equal to 1. Or there are other identities that have a 1 in it. You can use them. This next one uses the double angle identity on the formula sheet. And you can see it's pretty straightforward. X is cosine squared, y is cosine of 2t. So I started with the y equation, replaced it with the identity sheet, and it has a cosine squared right there, which I replaced with an x, and boom, you're done. The next one, we've got x is cotangent and y is sine, so they don't share a Pythagorean identity. So we're going to have to think of some other way. The only real thing first is cotangent, cosine over sine, and we said sine is y, so I put it there, and then multiplying to get the y on the left, I now have a cosine and a sine. So back to that original technique of squaring those and adding them together to get that 1, like that. So there's slight variations on what you might do. You might use any of the identities on the formula sheet, the basic ones you should have memorized. But typically, you're going to try to combine them, either adding cosine squared, sine squared, or subtracting the other pair. And there might be other variations where different identities come into play as well. So just keep practicing.